everybody. My name is Anand Inani, and I'm part of the organizing committee for IIT 2020. Hope you're enjoying the summit so far. We've had a number of talks in a number of different topics, going from cloud to logistics to COVID. Uh, Now we're just going to switch gears a little bit to hardware. And it is my pleasure to welcome two industry leaders from the Silicon world, Yong Soon from Samsung and Simon Segars of ARM. Yong is a Silicon Valley entrepreneur whose passion is building businesses and fostering emerging technologies that have potential to transform the world for the better. Currently, Mr. Sohn serves as corporate president and chief strategy officer of Samsung Electronics, and also the chairman of the board at Harman. He leads Samsung's strategy for global innovation, investment, and new business creation, and led the company's $8 billion acquisition of Harman. Simon, as many of you may know, is the CEO of ARM. Since joining ARM as one of its first employees, Simon has driven technical and business innovations to help transform the company into the leading architect of the most pervasive compute technology the world has ever seen. Simon helped steer the company through the 2016 acquisition by SoftBank, and in June 2017 was also elected to serve on the board of SoftBank. Now, you all may not know, but you're using ARM's products and CPUs on a daily basis. They power literally every single smartphone on the planet, and more importantly, a large number of the IoT devices that have also become totally pervasive in our daily lives. Nearly 200 billion semiconductor chips are now built with their efficient, low-power designs and provide the key architecture for the essential devices of modern life, from smartphones to personal computers to data centers. In this rare interview following the recent acquisition announcement of ARM by NVIDIA, Simon sits down with Yong for a fascinating deep dive into the future of computing, communications, and global commerce, including 5G, artificial intelligence, autonomous vehicle, and hyperscale networks. So please enjoy the talk. Take it away, Yong.
Hi, Simon. Good to see you again. Thanks for joining us for the next wave. During this pandemic time, it's really hard to do things face-to-face, but I'm glad at least we can be able to do this virtually. So let's start with ARM. I think, of course, I am privileged and been involved with ARM for many years as a customer, as a board member, as a partner, but not everybody knows ARM. So I think it'll be worthwhile for you to educate the audience about the role of ARM, what does ARM do, and a little bit of historical perspective as well.
Yeah, so, well, first of all, thanks for having me today. It's great to catch up. We've been friends for a long time. It's good to see you. So yeah, ARM is a slightly unusual business. We often get described as a chip company, but that isn't what we do. What we do in our core business is design microprocessors. But instead of putting them inside chips and selling chips, what we do is license the designs to semiconductor companies for them to use as a building block within much more complex devices that they're making. The company will be 30 years old in November, so about to celebrate a big milestone. And at the time the company got formed, semiconductor manufacturing technology was just getting to the point where it was feasible to start building much more complex chips that became systems in their own right. Up to that point, if you wanted to build a system, you took a bunch of chips which had individual discrete functions, and you built the system on a printed circuit board. And with each generation of process technology, we've been able to cram more and more transistors into a chip. And so that gave rise to the ability to put those systems inside a single piece of silicon. So when the company was formed, the idea was, well, we have this low power, energy efficient microprocessor. I wonder if it's going to turn out to be useful to embed that inside a more complex chip. We didn't know what the killer application was going to be, but it turns out that in pretty much every application, embedding a microprocessor, adding intelligence, turns out to be incredibly useful.
Mm-hmm. Yeah, I mean, I remember the discussions at the boardrooms, and we're looking at a number of applications, and it's just incredible how widely ARM architecture has been adopted around the world. And obviously for consumers that doesn't know much about ARM, they probably have no idea that they actually are living with ARM every day.
Absolutely, yeah. Yeah, the business model of licensing technology to other chip companies to enable them to put intelligence into a chip, to build an ecosystem around it, has proven to be incredibly successful. We have today over 500 different companies around the world building chips based on the ARM architecture. There's a big ecosystem around that, providing software and other design services to make that all happen. But the real kind of the real impact, though, is in all the consumer devices, all the devices that go into enterprise networks and drive the internet. There are just so many of them that are now based on the ARM architecture. Over the history of the company, there have been now over 180 billion chips built using the ARM architecture, which is quite an outstanding number. It took something like 11 or 12 years to get to the first billion chips. And now our licensees, our partners, ship more than 22 billion a year. I mean, it's quite incredible. There's something like over 700 per second being manufactured. The scale is just astronomical.
That is incredible number and incredible reach. For small company, they came out of Cambridge, and today it has a huge footprint that all of us in the world are living with. Anybody that has mobile phones, or anybody that has the automotive applications, or embedded applications like robotics, has ARM in it. You may want to give some perspective around what did it take for you to build such a, what I call the digital architecture of choice in today's world that came out of Cambridge, UK?
Yeah, I mean, I have to sort of pinch myself to think about just exactly what we've achieved. When I joined the company right at the beginning, I was lucky enough to be the 16th employee, and we were in a converted turkey barn in the middle of the Cambridge countryside, and the technology span out of a British computing company called Acorn. It was a joint venture with Apple. Apple wanted this processor to put inside the Apple Newton, if you remember that, the first digital personal assistant. We just kind of looked for other applications where this technology might be useful. We went knocking on doors and trying to convince people that if they wanted to put a processor inside their chip, it would be a good thing to help try and establish a global standard, a standard around which we could build this ecosystem that would drive down the cost of implementing a processor inside a chip. We knew from day one there was no way we could do everything ourselves. And so we set out to build a network of partners who were going to be able to use the technology and to prosper from using their technology by building their businesses around this standard. So the goal really, genuinely from day one was to create a global standard that would make it very efficient to put this intelligence inside chips. And that's turned out to be incredibly successful. That's the kind of philosophy that we've taken to it. Build the company based around partnership and ecosystem.
Samsung team really appreciate the partnership that ARM has given, and all of our mobile phones and TVs and others have an ARM architecture in it, like multiple of them in actually even one phone. So it just shows the power of the processors and ecosystem that the ARM team has driven. You also took this strategy of partnership and building an ecosystem of others to join in, which made it even stronger. But also you had an angle of providing low power, which I think if you think about traditional players, focus on more about performance at power, and is always driving huge power footprint. And I think what you have done in some ways, that idea of this innovator's dilemma coming from the below and just hitting it on the incumbent, not being able to even deal with the kind of equation that you've been working on, is an interesting lesson for how the new architecture can come. Of course, it took time, but it does show us that new architecture can come at a right time when you are patient and if you build ecosystem and partners. It's an interesting discussion that I'd like to get your perspective on this.
At the time that the company was formed, as I said, that semiconductor process technology was really improving rapidly, and it enabled computing to evolve in two different directions at once. There was the how much performance can I squeeze out of these transistors that are put into a chip, and my only constraint is how much electricity can I get from a wall socket, and that was one way to go. And then there was this idea that if you can eliminate as much power as possible, then you open the door to many, many devices which could then run on batteries. And that was the angle that we took. So we always looked for how can we simplify the design? How can we really analyze the design to look at where the power is being consumed and use smart circuit techniques, smart architectural techniques to make the processor as energy efficient as we possibly can. And so every time when we're looking at a new design, we're thinking, what is the trade-off? How much power have I got? And how much performance can I deliver with the technology within that power budget? And that's how we think about the design process. And then, the way our business model evolved, it was about licensing to others. So we really had to think about our success coming when that licensee of ours actually got into production. So as well as our own technology, we were thinking about who else do we need to work with? What about the companies that provide EDA software, the software that's used to actually design a chip? Let's go and work with them. Let's go and think about how quickly a chip designer can get through the design process using our IP and their tools. Let's think about the end manufacturing technology. So we're always thinking about energy efficiency. That's important in anything that you're carrying around in your pocket, of course, but it's actually important everywhere. And then how can we optimize across an ecosystem to produce the best result?
What makes it unique is the fact, unlike other players, you're not just making product, but you're making and building ecosystem so that the customer can be successful by providing the better tools and better alignment to the manufacturing, SKU, all those type of things. It's incredible what you have done to accelerate the development of new electronics by not being able to design these very traditional custom compute engines. And then you, of course, add other blocks like graphics and networking, as well as interface logics and all those different blocks that people need to build the chips. They made it easier for them to do it. So I think this whole idea of creating digital architecture is really a modular architecture. And I think ARM, in a way, pioneered it from traditional compute perspective, and you made a migration to much a next generation approach. And the question I guess I have is now, what's next coming, given that some of the announcement that was made by NVIDIA that wants to have ARM. So I'd like to get your perspective of what is your view of synergy? Why do you think NVIDIA will benefit by working with ARM to take care of and provide the benefits to your customers?
The applications for computing have grown and grown and grown over the years. The ability to put so much intelligence into a piece of silicon for such little cost has just driven an explosion of the number of end devices. And of course, we live our lives today with mobile devices, with just all this electronics that we take for granted. But whilst we've driven a lot of efficiency and advances in the compute engines that are in these silicon chips, the nature of that computing has been fairly constant over the years. It's running conventional code that's been taught in universities for years and years. There is a transition coming, though. Over the last little while, we've seen massive improvements in the field of artificial intelligence. And we look at the next generation of computing being a combination of classical computing and AI-driven computing, where data is being used to make decisions and being used to make decisions in an autonomous way through algorithms that are effectively using machine learning and AI techniques to extract information and look for patterns within that data. So I think the nature of computing is changing. We've been studying that. We've been expanding our own products to provide machine learning accelerators, to provide software frameworks to allow applications to be built. And NVIDIA have been driving that to huge success. Thinking about very high performance applications for AI. Now, both companies, we see AI just going everywhere, being as pervasive in the future as conventional computing is today. And we believe that if we take the strengths of ARM, the ability to create pervasive technology, to be able to create ecosystems around what we do, we take that and we add and we combine it with the strengths of NVIDIA, all the work they've done on really high performance AI compute, the work they've done on the software stack to enable applications to be built. If we put that together, we think that creates a really compelling future in delivering how we deliver this next generation of compute. So that's what's behind the acquisition.
Given the importance of ARM and its architecture for really number of devices that are based on what we call digital architecture, I think you mentioned 190 billion. Soon, by the time we are done with our interview, maybe it'll be 191 billion. It's accelerating. But, you know, the safety and security is something that people are really worried about as the architecture proliferates and reaching the mass number of devices. So I want to just get your perspective around what is ARM doing about the security?
Yeah, it's a huge subject for us, and it's a sort of horizontal technology that cuts across absolutely everything that we're doing. To your point, you can build like incredibly secure systems, and then you find it's the smallest, cheapest thing that created the entry point into the network. So specifically around that, we've been looking at how people build secure IoT devices for some time now. We introduced what we call the Platform Security Architecture, PSA, which is a set of guidelines for how people build very small, very low cost IoT devices, but have an architecture that then enables secure software to be built on top of them. So by defining the kind of building blocks that need to be within the chip, how to partition memory up, how to keep encryption keys away from main memory, how to partition algorithms, how to build a secure operating system. That's really important because in a world of a trillion connected things, a world of billions and billions of IoT devices, it only takes one for the bad actor to be able to get into the network, and we want to do everything we can to try and prevent that. We've also been thinking about how software on those devices get managed through its lifetime. Any computer that you might use, you can have operating system updates pushed to it if there's a security issue. We need that to be in place for absolutely everything that's connected to the network. And that's a huge piece of work that is ahead of us for the industry. And then, as you say, security needs to go everywhere. We're thinking about how big CPUs that sit in cloud data centers, how are the applications within them separated from each other? How does the hardware help support that? How do you contain something if there is, if some application does get penetrated? How do you contain it so it can't get into the rest of the system? It's driving changes in the base architecture. It's driving changes in the way that software is written across all of these devices. And again, we're taking a very partnership-based approach to try and help address these problems, working with people, thinking about what solution is going to be needed, not just tomorrow, but 5-10 years from now, and thinking through the changes in the architecture that are going to be required to deliver that. So it's a huge piece of work, but one that's crucially important for us.
As you know, when I was on the board, mobile phone was the major driver, and it was in two ways. The volume was going up, and it was hitting 1.5 billion units per year, and then they were shipping multiple ARM processor per phones. So this multiplier effect was really great for ARM's growth during late, I guess the 2000s and early 2010 era. But now with the mobile phone, a bit saturating because everybody has a phone. What do you see the next big growth for ARM going forward?
Yeah, I mean, the growth of mobile has been phenomenal for the company, and we've had two waves of it, the initial wave of digital mobile phones and then smartphones. And over the years, we've seen ARM technology being used in many other applications, but I think we're at a moment now where the growth of semiconductors looks really, really positive for the years ahead. And it's a number of markets that are driving that growth. We're seeing the deployment of 5G. 5G is way more complex than 4G, so it's driving the adoption of more processing within all of the chips that that build up the 5G network. And then on top of that, you have the growth of IoT. That's billions of devices. They're really small, but they're enormously high volume devices. That's a driver. We have autonomous vehicles, highly complex data centers on wheels that need to be driven, pardon the pun, in a way that makes them really energy efficient, but enables a massive of compute power to do everything that an autonomous vehicle requires. So there are all of these things going on at once, and this combination of AI as the kind of core element of processing, 5G networks, IoT, this is all happening together, and I think is going to drive the growth of the semiconductor industry for years to come. And then the other place that I did mention is the data center, and the cloud is growing like crazy. And that's another area where through our focus around energy efficiency, we're able to provide some real benefits there as the cloud expands with the performance that we're now delivering. We're starting to see more deployments of ARM processors in the cloud as well. And that's an area people, once upon a time thought we'd never be able to address, but today we are.
So a lot of these applications are very exciting, and actually these are all the footprint of what's driving the demand for the devices, as well as the applications that are making our lives better, right?
Technology and compute power can help improve our day-to-day living. But there are so many other areas where this deployment of computing, the deployment of IoT devices, the use of AI can be used to address some of the hardest problems that the world's going to face over the coming years. Things like climate change, things like growing population, things like pollution, everything that's encapsulated by the UN Global Goals. These are areas where technology can make a big difference, and it's something I know it's an area of focus for you personally, Young. I know it's an area of focus for Samsung, and it's something that we're big believers in, that technology can help play a role.
I actually do appreciate also being supportive of the initiative that I also started called Extreme Tech Challenge. Startup companies using technology and innovation, entrepreneurship to solve the sustainability issues. And I'm hoping that all of us in corporations, they can be able to work with startups to accelerate these innovations. So I'm going to continue to support and push Extreme Tech Challenge. And I also know that you have 2030 goals that you've been pushing as a part of same agenda in a different scale in the time frame.
Yeah, I think that the key thing about what we're doing in various different ways is this evolution of compute power has been incredible. It's giving us these mobile phones that we can play games on and do cool stuff, but the potential impact goes way beyond that. And what I've seen through ARM's history is if you continue to drive down the cost, if you drive up the performance, if you make it easy for people to get access to these technologies, then what you do is kind of spark their own imagination. You enable people to come up with the ideas that you couldn't have possibly have thought of, no matter how many smart people you've got within your company, because you've got these kind of business objectives that you have to deliver on. But if you can put all those tools in the hands of other people, then they come up and they create great ideas.
Well, thanks for sharing. I really appreciate that.
Well, thanks a lot.
Okay, well, thank you, Yong and Simon. Fantastic story indeed about how ARM's developed its technology, business model, and now it has evolved into a $40 billion company fighting against a strong incumbency to begin with. And thank you also for your insights into what could be the next set of innovations in the works for ARM, especially with the NVIDIA acquisition. So folks, thanks for joining this session on Internet of Everything. Next up at 2 p.m. is the keynote session by Ajay Gopal, the CEO of Ansys, whose tools many of you probably use on a daily basis in the engineering world. So thank you for joining.